Okay. So in the last class, we had discussed about structure of automobile, classification of IC engines, then importantly, the working of a petrol engine, ASI, and working of compression ignition, that is CI engine. Okay. Then different components of an engine. So main components are cylinders, piston, connecting rod, crankshaft, valve and valve timing mechanisms. So irrespective of whether it's a petrol or a diesel engine, so these components are at the most required. We had discussed about the general structure of an engine in this sketch. Then we had discussed about cylinder, different materials used for cylinders. Okay, cylinder arrangements. There are four important types of cylinder arrangements: inline cylinder, opposed cylinder, V engine and radial engine. So all four mechanisms we had discussed in the earlier class. Okay, so next, after cylinders, the next important component is the liner. So what are these liners? So liners are usually used to reduce the cylinder wear. Okay, cylinder wear, and hence to increase the cylinder life. Cylinder bore life has to be increased. So liners are used to reduce the cylinder wear and tear. Okay. So when these liners get worn out, you can just replace these liners. Right? Okay. Instead of replacing the entire cylinder block after driving a vehicle for say 1 lakh or 1.5 lakh kilometers, they talk of reboring the engine. So at that time, instead of going for rebore, you can just directly replace this liners. Okay, there are two types of liners. One is dry liner and the second is the wet liner. So please make a note of it. The definition of liner is they are used to reduce the cylinder wear and hence to increase the cylinder bore life. Okay, so when the liners get worn out, you can easily replace it instead of going for a reboring of the engine. So reboring is nothing but increasing the cylinder diameter and going for a new piston of higher diameter. Instead of doing that, we can just replace the liner. Okay, so there are two types of liners. First one is the dry liners and second is the wet liners. Now we will discuss one after the other. Okay, so we'll move with the first one, that is dry liners. As you can see in the second sketch. Okay, you can see here. So this is a dry liner. Okay, so this is the cylinder block. This is the cylinder block, whatever the black colored one you can see. So here exactly the piston reciprocates. In this area, the piston reciprocates. You can see over here. Here actually the piston reciprocates. If there is a direct contact between the piston and the cylinder, after a certain period of time, the cylinder or the piston may get worn out, so the gap increases. When the gap increases, what happens? There will be a leakage of gases. You can see some black smoke in some of the old trucks. Okay, when they accelerate it, more black color smoke. So what is it? The uncombusted fuel particles just right away escape from the gap. Okay, in such cases, they will go for reboring. Reboring is a technique where you will increase the diameter of the cylinder, okay, by machining this surface and going for a new piston with a higher diameter. So instead of that, you can use a structure called as liner. You can see here. So this is an example of liner. So this liner is placed over here. So liner. So this portion is the liner. Whatever you can see the steel structure. So this is the liner. So this liner is like a cap. It will be placed like this, and there are some hooks you can see in this region. It can hold. Okay, in the cylinder block, so it can firmly hold. So the piston reciprocates in this region. Okay, there will be a direct contact between the piston and the liner, not the cylinder block. Once this liner gets worn out, you can replace the liner straight away instead of going for reboring and using a new piston. So that is the advantage of using the liner. Okay, you can just make a rough sketch of it. Before that, dry liners are thin and uses a metal block to give the full length support. As we saw in the sketch, complete cylinder will be covered by this liner. The liner and piston comes into contact with each other. The flange, what do you mean by flange? This portion is called as the flange. So this portion is called as the this ring is called as the flange. That flange will fit into the cylinder block so that it cannot move up and down. Rigidly it fits so that the piston can move inside. Okay. The flange is provided at the top, which keeps the liner in position. The liner surface has to be machined accurately. So the machining should be accurate both inside as well as outside, correct? To maintain the perfect gap. Okay. So you can see here. So this outside surface comes in direct contact with the cylinder. Inside surface of this surface comes in direct contact with the piston. Okay. So that both the surfaces has to be machined accurately. Okay, I hope you understood what is the function of liners now. So please take down a rough sketch. This you can take down the sketch. Make it fast.
Sir.
Yes. Yes, please.
Right, sir.
Okay. So we'll move to the next dry liners. Okay. So sorry, wet liners. Just take down a rough sketch. I'll explain you the concept. Take down.
Yes, sir.
Okay. One second. See, this wet liners are somewhat different from dry liners. Okay, so their functioning may be same, but the principle will be different. So they are supported only at the top and bottom. Throughout the body, they will not be in contact. Okay, so this is the cylinder block and this is the liner arrangement. There are some grooves to support them. Okay, so wet liner is pressed into the bore. Okay, so this is called as bore of cylinder block, and it is supported only at the top and bottom structures. Okay, so liners will be making direct contact with the cooling water on one end. See, on the outside of the liner, it will be in direct contact with the water. Okay, so cylinder head water which will be cooling, so that you need not machine it accurately. Only the inner surface, somewhat it comes over here. Okay, at the second line, only the inner surface which comes in contact with the piston is to be machined accurately. Okay, so there will be 3 grooves provided at the bottom. Okay, so these grooves will be packed with rubber sealings. Okay, so they are help in avoiding the leakage of water, cooling water through this. Okay, so the only difference between the dry and wet liner is one end of the liner need not be machined correctly. Only the second end can be machined directly. Okay, so that it comes in directly contact with the piston, whereas this end directly comes in contact with the cooling water. So it need not be machined accurately. Okay, so only at the top and bottom surfaces it will be connected to the cylinder, so that the cost of the liner may come down, but its functioning is same as that of the dry liner. So this is with respect to liners. Okay, so the next is the piston. So far we have studied the cylinder block. After the cylinder block there will be a liner, then comes the next important component, that is the piston. So here before going to the actual sketch, we will just see this actual figure. Okay, so this is called as the piston crown. There will be 3 rings here. The top one is called as the compression ring, second is also a compression ring, and third is the oil control ring. Usually the first ring, please listen carefully, the first ring helps in sealing the gases. Okay, so here it helps in just avoiding the gases from flowing outside. Say for example, this is the cylinder block. So here there will be a cylinder block, just a rough sketch I am drawing. Okay, within this the piston keeps on reciprocating. So this top ring helps in sealing the gases within the cylinder. It will not allow to escape out. Okay, the middle ring does the function of sealing the gases as well as avoiding the oil from leaking into the engine. Outside there will be lubrication oil. If it comes inside the engine, it will be burnt. In some vehicles you can see engine oil will be consumed in olden days cars, if you see, or old trucks. Okay, if you load, say for example, if you load 1 liter of engine oil, after 6 months when you change, 1 liter of hardened oil should be there roughly, or say 950 or 960 ml. If it is reducing, it shows that some leakage of oil into the combustion chamber is taking place. So the oil is burning inside the cylinder, which is not good. Okay, the second ring helps in blocking the combustion gases as well as avoiding the oil from flowing to the engine. The third is a oil control ring. Okay, even if it escapes from the second ring, at the third ring it will be completely blocked. If this ring gets worn out, then the gases starts escaping and the oil starts escaping into the cylinder. Gases will escape out, oil will escape in. So this will be the problem. Okay, so this is called as the crown. Crown is followed by 3 sets of rings. Top compression, middle is also called as compression, but it does a dual job. Third is called as the oil control. Next, the next important is the wrist pin, or also we call it as gudgeon pin. Okay, in the next slide I'll show you why it is used. Okay, and the wrist pin and snap ring are the important components. Okay, see here there are 3 rings. The region below the 3 rings is called as the skirt of the piston. Okay, so this entire structure is called as the piston. Okay, followed by connecting rod, connecting crankshaft, all that other components will be there. So this entire arrangement is called as the piston. The important components are, important regions are, the first is the piston crown, followed by there will be 3 rings. First one is compression, second compression plus oil control, third is the oil control ring, followed by wrist pin or gudgeon pin and the snap ring. Okay, and the region below these rings is called as the piston skirt. So these are the various regions of the piston. Okay, so this sketch will be helpful for you the exam point of view. You can see here there are 3 slots here. The first one, in the first one you can fit up the compression ring. Here again the compression plus oil control. Here there will be a oil control ring. So 3 rings can be fit up like this. The region below these rings is called as the skirt. Okay, they are in the third ring. There will be oil draining holes. If any oil blockage is there, it will be sent back. Okay, and this is the crown. Okay, crown are the topmost region. Okay, so you can take down this sketch. This is a helpful exam point of view. You can easily draw it. Please make a note of this. See, I have taken both the set of sketches. The first sketch will be easy for you to practically analyze and understand. The second sketch I have taken from the textbooks, so that it will be easy for you to draw in the exam. Okay, so if they ask you to explain about the piston, this sketch is enough. Please make a note of it. Make it fast. Is it done?
Yes, sir.
Okay. So as we discussed, these are the various parts of the piston. The main function of piston is that it is a reciprocating part of the engine. Okay. So whatever combustion pressure will be there inside the cylinder, it will be converted to a mechanical energy because of the reciprocation of the piston. Okay. So clearance is given between piston and cylinder so as to provide some lubrication. Usually we will be using aluminum alloys. Okay. In our modern automobiles, as I told you, the top portion is called as the crown of the piston. There will be 3 rings followed by piston skirt. Okay, so this is regarding the construction. Its main job is to convert the combustion energy or heat energy or pressure, whatever is built up in the cylinder, into mechanical energy. Okay, same thing is explained here. It is the reciprocating part of the engine. It will convert the combustion pressure to a force on the crankshaft. That is mechanical energy. So there will be a clearance between piston and cylinder so as to provide proper lubrication. So usually aluminum alloy pistons are used in modern automobiles. Yeah. So this I have already explained about the